everyone, I'm Aisha Chaudhary, and this is the third demo of this Java internship. Today's topic is Spring Boot layers. Firstly, we'll understand this topic and then we'll move ahead to perform a task that was given to us. Okay, so what are these Spring Boot layers? In Spring Boot, the architecture is typically organized into several layers, each with distinct responsibilities. This layered architecture helps to separate concerns and promote maintainability, scalability, and testability. So overall, Spring Boot's architecture is divided into multiple layers that has its own feature for the overall application that we'll build. So let's have a look at the layers first. Okay, so for now, we'll be discussing four layers that are very important and need to be understood by everybody who is learning Spring Boot. So the first layer is presentation layer. It handles user interactions, processes user input, and displays information. It also acts as a communication interface between the user and the application. It is also called controller layer. Basically deals with the HTTP requests of the client and then gives a response to it. It talks with the service layer and then based on the response that it gets from the service layer, it responds to the user. Okay, and four type of operations or API requests can be called in presentation layer or from the controller, that are get, post, put, and delete. Get is used to retrieve the data, post is used to create a new dataset, put is used to update the existing data, and delete is used to erase or remove the data present in the database. Now, let's move ahead to service layer. Service layer implements business logic and processes data before sending it to the repository layer or returning it to the presentation layer. Service layer basically performs the operations or the main logic of the system that we are building. It could be the CRUD operations or other functionalities or processes that are to be done for the system. It interacts with the repository layer and gives a response to the presentation layer. Now, we'll talk about repository layer. It manages data persistence and retrieval. It provides an abstraction over the underlying database. So it retrieves the data from the database and gives it to the service layer for further operation. It is a repository that provides inbuilt functions for the CRUD operations. Model layer represents the domain model and contains the core data structures of the application. Basically, the database data, the variables and other the values, basically the data values in the database. It is stored in model layer. So this is the diagram to better understand the architecture. So first, this is a client. It sends an HTTP request to the controller layer or the presentation layer. Okay, it takes the request from it and gives it to the service layer. Basically, the data that is to be processed in the service layer. Service layer takes the data from the model layer, performs some operations, and if it requires something that is related to CRUD operation, then it takes the functions that are present in the repository class. That was the repository layer. And then we have model. Model deals with the database and its data and provides it to the service layer. It basically contains entities and data models that are used to create tables and have values, multiple variables, and those users' data in the database. Okay, so service layer interacts with model layer and controller layer, and then controller takes the data from the service layer, returns it back to the client. Okay, so this was the overall architecture flow of a Spring Boot application. Now we'll move ahead to the task that we have to perform. So this is the task that we'll be performing today, or let's say we'll understand it in more detailed way. Strong understanding of core payment status system. Okay, we have multiple status. We remember created, initiated, pending, success, and failure. Those were the five status in a payment status system that will denote the current or a payments situation or the current status it is in. It's invoked at multiple places, and for each status, different logic would be needed, obviously. So we need to design a modular system. So what's a modular system? Basically, of our whole project, when we divide it into smaller units called modules, which are specifically coded for a single functionality only. So that system is called modular system. It contains multiple modules or units. Those have different functionalities, but only one specific function for the project or system. For example, if we have a school management project or system, then we can divide the system into multiple modules like grading system, assignment system, student management, attendance. So for these four operations, instead of coding the whole thing in one class or one place, we can divide it into multiple classes or multiple modules, code each functionality differently and at a different place, and then it will be more testable or manageable and easy to understand. So let's move ahead. So the first thing is approach one, all code in one service class and methods handling all business logic. Let's come back to our presentation and understand the first thing. Approach one, start with a single service class which contains all the business logic related to handling different payment statuses. So it means it says that we can code the whole status logic in just one class, handling all the cases and writing the coding logic here, everything at one single place. Okay, so we can see that this is a payment status service class in the service layer. Of course, it has a function process status, and in the parameter it takes transaction object of the transaction class, the data object or the class that deals with the database. Then we have a switch case transaction.getStatus. We are getting the current status from the transaction object. Then for the case created, we'll write a logic, some logic that will deal with it for the payment, and then case pending, and then multiple cases we can write in it. Okay, so this approach is really faulty and has many drawbacks related to it. The first one being it is not maintainable. Okay, the class becomes very large, and as the system grows, it becomes really difficult to maintain. It doesn't have any modularity logic and is very tightly coupled. If any error comes, it is really hard to detect or find where it exists. Also, testing is really difficult in this situation, and it is also not scalable. Now, let's move ahead to the first improvement. Okay, the second improvement says extract each status related logic as separate methods and invoke from service method. So it says that it follows the approach one only, that everything is placed into the single class only at the same place. But instead of writing the logic in the case part, switch case part, we are creating a separate status handlers or status handler functions, separate functions to handle the logic, and then we'll call it from our case part. So it makes the first approach a bit relaxing and easy, but still it has a lot of drawbacks just like the first approach. Even if the logic is separated into methods, the class still holds all the responsibilities, doesn't have any modularity. I mean, it does, but still it is not easy to understand. If the class size grows, meaning the new methods are added for separate more functions for in the future, then the class becomes very large and difficult to manage. It won't be very scalable and would be really difficult to find errors as well. So this is not working as well. Now let's move ahead to third improvement, or we can say second improvement. This was the first one. Yes, so it says separate classes for each status. Move each service logic into separate class, and in service create objects of those classes and invoke. As payment is core part of payment processing service, we can expand the code like this. Good for open for extension, close for modification, and also easy to understand and maintain. So basically creating separate handler classes for all statuses like created status handler and pending status handler and more, while writing the logic for those handlers in these classes. So in this first improvement, like just before one, we were creating different or separate functions for each handler payment handlers. But this time, instead of creating a separate function, we are creating a separate class for each status handler, like created status handler and pending status handler. And we'll write the code or the logic for that in those classes only. Let's see the code. Okay, so this is the payment service status service class, and we have created separate classes for status handlers like created status handler, pending status handler, and more could be added like success status handler, failure status handler, and much more. So we'll write that here in these functions handle, okay, same name, and we are doing the same operation, okay, writing the logic in this function only. Then we'll create its object in this class, the main class. Will create objects for those both of the handlers or other handlers, all the handlers, okay. And then in process status we do the same operation, but in cases, instead of calling the functions directly, or like when it was present in the same class, will use the object to call the functions that are present in those classes for the processing, the main logic. Okay, so yeah, it modifies the main approach and makes it a bit easy, but still it has some drawbacks too. Like the code is still complex, and managing multiple classes can increase its complexity. The number of classes increases as each status has its own handler, potentially leading to many small files. Okay, this could take up a lot of space. It could lead to code duplication and error handling is still a bit difficult here. Now, let's move to our third improvement, that is all status handlers to have common parent, have common method for all, and each handler implements code in service based on interface to invoke these methods. Now, we will create a one parent interface like payment status handler, which will be inherited by child classes like created status handler, pending status handler, or success status handler, and etc. Those classes will have their own business logic, but still they will integrate the functions from the payment status handler or their parent interface. These classes will inherit it but have their own functionality given to it to process the payment system. Now let's see the code. Okay, so this is the parent interface. Okay, payment status handler. It has a function void handle. It takes the transaction object and the first class status created status handler. The first one. It implements payment status handler, the interface, overrides its function handle, and we can write the separate logic for it, whatever which is required for created status. And then the payment pending status handler, the same thing and a different logic for it in the function. And we can add many other classes too, like success status handler, failure status handler. It would have their own business logic for it, but the function declaration would be same as here. And then we'll come to this main class, public class payment status service. Okay, so here we are creating the object of the payment status handler, then getting the transaction.get status, the status from the transaction object, passing it to the get function, or yes, basically not passing it, we are getting, or yeah, we are getting the status, and then if it is not equal to null, we are passing it to the handle functions, to those classes or the created status handler classes which have their own functionality. Else if it doesn't work, then we can handle the exception, whatever it may be. Then we'll move ahead to our fourth up improvement. Okay, so it says implement factory design pattern. The factory determines which handler to create based on input parameters and returns an instance of the common interface type. So let's understand what is factory design pattern. The factory design pattern is a creational design pattern that provides a way to create objects without specifying the exact class of object that will be created. It defines an interface for creating an object but allows subclasses to alter the type of objects that will be created. This pattern is particularly useful when the creation of an object is complex or involves a lot of logic. Basically, creating an interface for creating objects in a superclass. Okay, and then these subclasses can alter the type of objects that will be created. Okay, so let's see the code to understand it better. Here it is. So we have a payment status handler factory, and then inside it we have a get handler function that has a return type of payment status handler. Its parameter list contains status enum status. So status enum might be a class or constant in the constant package, which has different types of constants that would be used in the overall system. So here, when the case is created, a new created status handler object will be created, which will go to the which will go to the created status handler class, which will have its own logic and it will all be performed. And in the case of pending, a new pending status handler classes object will be created and the its logic will be performed. Okay, and the additional cases, the other ones, and a default statement. So implementing a factory design pattern promotes encapsulation for the logic of the program, and a centralized object creation is there or created. The code is flexible, uh, easy to maintain and understand, and the main thing, it loosens the coupling, the tight coupling of the classes. The factory pattern may get a little complex to understand, having different parameters and conditions, but still it, it is manageable and more modular than the first approach that we did. The next improvement was to utilize the factory in payment service to get reference of handler and invoke the process method. Use the factory within the payment status service to obtain the appropriate handler reference dynamically. It separates object creation logic from the client code that uses those objects. This makes the code more flexible and maintainable because changes to the creation process don't require modifications to client code. Let's see the code to understand it. Okay, so this is the final payment status service class, and it has payment status handler factory that we understood before, and it creates a new object, and in the function process status that takes transaction object, the payment status handler, a new object is created which uses factory type to call the get handler function that uh, gets the value status from the transaction object. It returns status, and the get handler functions return what kind of handler is to be created, the created handler or the pending handler or whatever, and then it gives it to payment status handler. It will be stored in it, and then it will call the handle function, which we saw here. Those separate classes that had handle functions that had their own business logic for the current status or to process the payment. So this is the final thing. It has some really good benefits, like the Service class is really simplified and extensible, or we can say scalable, and testing could be easy too. We can find errors. The coupling is loose and it is overall easy to understand too. A bit complex, but if we could move, if we could put more effort to it, this is very useful to create projects. And in conclusion, this process, or with the help of this process, we can design a robust and modular payment status system that adheres to key software design principles. So we are done with this task, and now we can move ahead to our next process. Let's talk about Spring Boot annotations. So Spring Boot annotations are a form of metadata that provides data about a Spring application. Spring Boot is basically built on the top of Spring framework and contains all its features. And annotations are used to provide supplemental information about a program. So what does the program actually doing? It does not have a direct effect on the operation of the code they annotate. It does not change the action of the compiled program. So let's see. Firstly, we have Spring Boot application annotation. So this annotation is used to mark the main class of the Spring Boot application. So the main Spring Boot application that we will create or build will run with Spring Boot application. This is the main entry point or the main part of the application that will make our program runnable. It encapsulates Spring Boot configuration annotation, enable auto configuration annotation, and component scan annotation. See, we can see that in this diagram that it has three annotations combined to it. The main class that will run the application, Spring application dot run. This is the name of the project, and this is the annotation used here. We have Spring Boot configuration. It is the class level annotation that is part of the Spring Boot framework. It implies that a class provides Spring Boot application configuration. Next, we have enable auto configuration annotation. This annotation auto configures the beans that are present in the class path. Next, component scan. It tells Springs in which packages you have annotated classes that would be managed by Spring. So for example, if you have a class annotated with controller, which is in a package that is not scanned by Spring, you will not be able to use it as a Spring controller. Controller basically lies in the presentation layer, which we talked about earlier. So this component scan basically scans the uh, annotated classes that the classes that is to be managed by Spring container. Then we'll move on to request handling and controller annotations. First one, we have @controller. This annotation provides Spring MVC features, model view controller. It is used to create controller classes and simultaneously it handles the HTTP requests from the clients. We can make a class controller just like this, @controller. Then we have REST controller. This annotation is used to handle REST APIs such as get, put, post, delete, and also to create RESTful web services using Spring MVC. It encapsulates @controller and response body annotation. So @controller annotation plus @response body. The annotation is equal to REST controller. Here's how we can use it. Then we have request mapping annotation. This annotation is used to map the HTTP requests with the handler methods inside the controller class. Okay, and then for handling specific HTTP requests, we can use get mapping, put mapping, post mapping, patch mapping, and delete mapping. Get mapping is basically used to retrieve the data. Put mapping is put and patch. Both are used for updating the data. Post mapping is used to create a new data, and delete mapping is used to erase or delete the data. Then we have request param annotation. This annotation is basically used to obtain a parameter from URI. In other words, we can say that request param annotation is used to read the form data and binds the web request parameter to a specific controller method. Here we can say it, the author name, the parameter coming from the URI is mapped to this string get authors function with the help of @request param annotation. Then we have path variable. This annotation is used to extract the data from the URI path. It binds the URL template path variable with method variable. See, here it is taking the value from the URL, and then with the help of path variable, we are taking the name of the value that we have to use in this function. And we have request body annotation. This annotation is used to convert HTTP requests from incoming JSON format to domain objects directly from request body. Here, method parameter binds with the body of the HTTP request. So, for example, in Postman, if we give the body in JSON format, like the whole object, then it will come to the controller in the form of like object. Here we can see. So request body annotation is useful for that. Now we have response body annotation. This annotation is used to convert the domain object into HTTP request in the form of JSON or any other text. So we have response body annotation here. Now we are creating a new object, setting the name, setting the age, and then returning the whole object. Okay, so we are done with the annotations for now. Apologies for the mistakes I have made in this video, and thank you for the opportunity. Thank you.